Cool. Hi, I'm Mike. I work at Countingup. I'm not very good at coming up with titles for talks. Never mind. That's me on social media. I don't promise that I'll post anything interesting. Probably going to hold questions till the end. I'm going to do a bit of a live demo. We'll see how that goes. If you pray to demo gods, do so now. We're Countingup. We are the business account that does your books. We essentially have much of the complexity of a challenger bank, along with all of the complexity of accounting software. So we worry about things like real-time data processing, data integrity, idempotency, high availability, security. It's a lot of fun. We mostly go after sort of one-person businesses. These are apparently happy customers, but that's kind of our sort of laser focus, the sort of one-person company who are just really trying to get on with their business and not do accounting at all. Not really here to talk about that, though. Here to talk about Go. Hands up if you've heard of Go as a programming language. Good. Hands up if you've written any. Okay, so not all of you are going to be bored. Excellent. Hands up if you've got some Go running in production. You brave people. For those who don't know, Go was designed at Google back in 2007 by these fine gentlemen, mostly because they all hated C++ and wanted something better. It was announced publicly in 2009, was open source from the beginning, statically typed, compiled, very similar to C, has wonderful things around memory safety, garbage collection, concurrency. Everyone refers to it as Golang, because if you've ever tried Googling for Go, it's really not very helpful. We love Go. I mean, we really love Go. Why do we love it? We love the tooling. Compiles really fast. You can compile down to statically linked native binaries, no external dependencies. That's all built in out the box. Formatting, linting, vetting, unit testing, benchmarks, documentation, you name it, Go has a solution for it. It's thus very opinionated. Very simple language specification. The focus is on readability and usability. The tooling enforces that and enforces good style. There's no such thing as a compiler warning. It's either an error or it compiles. Usual kind of bad code smells, unused variables or imports, cyclic dependencies, implicit conversions of types. These are just not allowed. The compiler will throw a fit and say sorry. It's quite good for performance too. You get nice compact binaries. There's no other additional external runtime. They don't need much memory either. So I think our largest backend service, the binary, is 30 megs. At the startup, it's consuming 56 megs of RAM. And this is all native code with native code speed and performance. It's also quite handy for security. A lot of your sort of typical security faux pas when you're programming have basically been designed out. You can't do a buffer overflow. You can't do a use after 3. Also, that static binary, all it needs is an operating system kernel. It doesn't need any of the rest of the operating system, so you don't have to worry about it. You haven't got endless Linux packages to patch and maintain. I'll talk a bit more about that later. So, how do we use Go? That's our stack. There's a bunch of JavaScript stuff at the front that's web and mobile. It's moving from JavaScript to TypeScript. Apparently that's better. I'm not a front-end developer, as you may be able to tell. We've got about 20 back-end services stuck in the middle there, all written in Go. Some are microservices, some are less micro. It's something we're always working on. They all expose RESTful interfaces with JSON payloads. There's no gRPC or protobuf or anything clever here. Everything is very simple, very easy to read. We've got Docker and Ranch as our current container platform, although we'll probably be replacing that with Kubernetes later this year. And it all sits on top of a load of AWS. The odd thing to the left, prepay solutions, they are our access to the world of banking. They provide us connectivity to faster payments, MasterCard, the ability to handle direct debits and all of that stuff that lets us be a functional banking solution. So, enough about that. I shall now try and do some live demo-based joy for you. So, it's Hello World in Go. Pretty straightforward. We've got one package which is main with a main function. We've imported the format package, done format print line, Hello World. Nice things there. Note the emoji. Everything is UTF-8 happy. And so if we go into Hello World directory, we just need to do a go run on the main.go, and it says hello world. with the emoji. So emoji in, emoji out, full UTF-8 pipeline. Very happy. It's not really a microservice, so let's go look at something a bit more interesting. So we've got, I'll start at the top. Again, package main, we're not doing anything complicated package-wise here. A new import, which is goes net HTTP package. That's really quite powerful. The built-in HTTP package will spawn Go's lightweight Go routines, which are like very lightweight threads for every request it needs to handle. So out of the box, you can handle quite a significant load as long as you've got enough CPU and RAM to handle it. It is that simple. We've defined a handler function to return hello world. I'll come on to the commented out stuff later. We've set up that that handler is linked to the root path, so that's a kind of very basic HTTP request routing, and then we're listening on port 80. So if we go have a look at that. Usual firewall nastiness. We should have something listening. So because I can never remember the magic curl incantation, we got hello world back. So we have a functioning thing that's listening on HTTP that we can ask questions of and get back. So that's a pretty good start, but a bit boring. So what if we were to do something more interesting? So a new function message takes in an HTTP request, gives back a string. We're not actually using the HTTP request initially. We'll come on to that. Oh, no, we are. I take it back. So yeah, we're getting the query parameter from the URL, looking for something called name. If name is blank, then we'll use world, and we're returning a string that is concatenating the two together. We're now going to use that inside our handler. And so if we go back here and make sure I've saved the file, run that this time. We run our curl, we should still get hello world. Okay, we're missing a line ending, never mind. If we add question mark, name is Mike, we should get hello Mike. Can you see that? Yes, it worked, super. That's great. What if we don't want it to be a query parameter? What if we want it to come off the path instead? Well, then we would go and grab the path. That's erroring out because in order to grab the path, I need to string the prefix, so we need the strings package. So we'll run that. If we grab the root, we get hello world. If we get a /Mike, we get hello Mike. So really basic HTTP type stuff. It's quite nice. Gets hard work as you add more and more roots, more and more interested in sort of query parameters or components of the URL path. You end up with a lot of code that looks really similar, not very dry, not very happy. And it sort of gets worse if you've got lots of services as well, when you lose track of which services have which roots and what parameters those roots accept, especially when you get into the world of posts. It'd be really nice to have some docs, but the wonderful thing with docs is as soon as you write them, they become out of date. So you've got that joyous task of maintaining them. Also, you need to make the documentation available. Maybe it's on a wiki, maybe it's in your GitHub README. So what we've done instead to try and make sense of this all is we've adopted some tooling called Swagger, which implements what's now known as the Open API specification. This is a Swagger specification in YAML for our demo service. It says that it's HTTP. It produces plain text. At the /path, it takes a get. Operation name is get greeting. There's parameters there in the query string for name, which all looks pretty nice. But it's just YAML. What do we do with that? So we use some tooling from the Go Swagger project, which is an implementation of Swagger for Go, which lets us generate code. So if we go into the Swagger directory, so we're going to ask Swagger to generate some server-side code based on that YAML file, and we don't need it to provide a main function because I've got one of those handily. And we run that away. It generated a bunch of code. If you don't believe me, it's all sort of hiding in here. So we've got operations like get greeting. And this is basically all of your boilerplate. So there's an underlying model here. All of the boilerplate around request handling and responses has been done for you. So that's pretty handy, and it's all generated code, and if you update the definition, you can regenerate the code. And all we need to do now is use it. So we've got a main.go here. We're importing some stuff from the REST API and the REST API operations, which is the generated code. We're importing a few bits from the actual Go Open API solution. We've got a main function where we sort of load in the Swagger spec and do initialization, and then we set up a server, and then we do some nice cleanup. So if we run that, it should be listening on 8080, and we'll curl it, and it says unprocessable entity HTTP 422 message naming query is required. Interesting. Why is that? So when we put our Swagger YAML together, we said that our query string parameter was required. So out of the box, the fact that that's required has been handled for us by the framework, and it's returned the right HTTP status code for you've done this wrong. If we were to take that out, then we can regenerate our wrong window. Regenerate our Swagger code. We run our binary. Curl it this time. What do we get this time? 501, not implemented. Operation get greeting has not yet been implemented. This is really helpful stuff. So that's because we haven't implemented the operation get greeting. So let's do that. So we say that the handler for get greeting is this handler function. That handler function is defined up here with a payload of hello world. So we don't need to run the Swagger generation again. We've not changed the YAML. We just need to rebuild and rerun our binary. And if we do a curl now, we get hello world. So we're back to where we were. It's great. Where's my browser? That's got docs. So at the /docs API endpoint on that very service that we just compiled and ran is fully hosted documentation out of the box. It's nice. It's also definitive because it's the service that's running, and therefore it's that service's documentation. We can also use this to do obviously more advanced operations. So we were doing the name parameter stuff before. If we go and import the few missing libraries, then you get hello world. If you do the question mark name equals Mike, you get hello Mike. If you refresh the documentation, the fact that the documentation takes the query parameter is all there, and you can see that it returns a string. So that's pretty good. What if we don't want to do the query parameter? What if we want to do it in the URL path instead? Then we go into the Swagger YAML, and instead of query here, we say path. We will need to rerun our code generation routine because we've changed the Swagger YAML. Bear with me. Oh, yes, I made a minor error. Because we're moving to the path, we actually need to tell Swagger where this variable lives in the path, so we're saying it lives after slash. See, this is why you should never do live demos. Blah, blah, blah. Pass name, must validate only one schema. Okay, I'm not going to debug that now. But in essence, you can just change the Swagger definition, regenerate the generated code. You'll note that there was nothing at any point in this function about where the name was coming from, so actually the code you've written doesn't need to change just because you've moved from a query parameter into the path. So this can be quite powerful if you want to sort of change the structure of your APIs without needing to rewrite swathes and swathes of code. So that's sort of Swagger. It's tooling we use to help make our services understandable to the rest of our team, helps us avoid writing boilerplate. We use it with Go. How am I doing on time? 5 past. Then let's go have a bit of a look at some stuff with Docker. So we run all of our services in Docker. We use Docker containers a lot. It's a really good piece of packaging for us. It's a really nice asset that we can version, maintain, and ship stuff around with. So you can use Docker to build your Go binary, sort of just like that. So we're taking a public Golang image, bringing in our source code, running go install. The tags thing is basically to make sure we get a static binary. And then we give ourselves an endpoint. So give myself a bit of space. This will go away, do a Go compilation. I've got all of the layers cached, so this shouldn't take too long, I hope. Super. So I've now got an image locally. Let's spin up a copy of that. Excellent. It says hello docs. That's pretty nice. This is back to the basic hello HTTP that we were doing before, so it's just taking docs as the name. So it's the same binary, just inside a Docker container, still listening on port 8080. If we go inside that container, you see we've got things like Python and then Perl and things that we don't really need. It's quite bloated. In fact, it's very bloated. It's 790 megs. It's not really what I was selling you on earlier about having a nice small footprint. But most of that 790 megs is coming from the underlying Golang container. So clearly that's full of stuff we don't want, need, or desire. So instead, we can do what's known as a Docker multistage build. If anyone's familiar with this, sorry if I'm telling you things you know. So we do the same as before, but we name our first stage as build. You name it whatever you want, it's just convenient. And then we copy the binary that we built from build into another container, which we've just based on BusyBox, which is a nice lightweight set of Linux utilities that can be incredibly useful. So if we rebuild hello HTTP using the multistage file, that was nice and quick. We now have a look. So hello HTTP is now 8.5 meg. That's much nicer. We can cope with that. That's got a full HTTP stack, TCP stack, everything else. And if we go, bear with me. If we kill off the previous container, yeah, thank you. Never do live demos. And then, excellent. And then if we go inside Slim, we've got no Python, we've got no Perl. That's pretty good. And you saw that it was 8.5 meg. There's a bit more fat here because BusyBox is almost 1.5, so we could do better. And indeed we can. So Docker has the concept of from scratch. This is an empty container. It contains nothing at all. So if we rebuild our Slim container now, Docker kill Slim. Rebuild the container. Just make sure that's gone. And then run that. If we get a shell inside Slim, we can't get a shell inside Slim. There is no shell. There is no Linux user space of any kind inside that container. There is just one static Go binary. In an ideal world, that's actually how you'd run stuff in production. And it's now only 7.3 meg. We tend to run stuff with BusyBox because on that very, very rare occasion that production goes wrong, not being able to shell into a container is a real pain in the ass. So we will take the fact that we need to keep an eye on BusyBox and make sure that we redeploy all our containers if BusyBox changes or has a security vulnerability, for the fact that in an emergency it gives us a bit of utility. I thought I'd finish finally by standing up one of our sort of real services. We've got some make-based tooling that wraps around Docker Compose to sort of make our lives easy at Countingup. But hopefully this will start up. And bear with me. I think I've got a port conflict. Yes, I do. HTTP. No. There we go. Give that another try. Excellent. This is a real part of Countingup. This is our address lookup service. It's quite simple. It exposes a couple of endpoints. One lets you find the closest matches to an address. One, given a postcode, returns a list of possible addresses at that postcode. And like all good microservices, it's got a health check. It tells you whether it's happy or not. We do our health checks with both head and get. So head is just going to give you a status code back. 200 is good. Anything else is bad. The get has a JSON payload body that will actually tell you what's wrong. Again, self-hosted docs, definitively correct because they're being served out of the service that's running. So, a couple more things. So this is Swagger, started back in 2011. The whole point was to both generate documentation and generate initially client-side SDK code generation. That's now been extended to do the server-side as well. We do both at Countingup. So if you want to talk to a service, you generate the client-side code from its YAML. If you are the service, you generate the server-side code from the YAML. Initially, it was JSON only. YAML was added later. We're very glad. Hand editing JSON files is really painful. They've since split off the specification into Open API, and Swagger is now the tooling. So you'll kind of see the terms used interchangeably, but it is all the same stuff. I have a bunch of useful links. I'm happy to share the slides. There's some stuff on Go, some stuff on Docker, some stuff on Swagger and Open API, if that's helpful. And we're hiring in London if anyone wants to come to London and do this kind of stuff. Questions? Was that a bit fast? Go on.
Were you tempted to use any of the frameworks like Buffalo or something to give you more of a wrapper, tools and other bits than just...
We did consider it. We spent some time trying to figure out how we could fit Gorilla under Swagger, and in the end decided it wasn't worth it. Sorry, so the question was, did we consider looking at other frameworks like Buffalo? I was saying that we tried to fit the Gorilla framework for sort of muxing underneath the Swagger tooling and just struggled to make it work.
Oh, okay. thought most of them had like Buffalo as Buffalo Swagger.
Possibly. Gorilla didn't. We didn't look at Buffalo specifically, actually. Any other questions? Up at the back.
Talking about shelling into the containers, why are you not happy not being able to do that?
I think it's mostly a confidence thing from back when we were a small team. It's not very easy to do. You've got to hop through several systems to get anywhere near them these days. So I can't remember the last time we did. But having to track busy box as a dependency is not really hurting us. It's only costing us 1.5 mega container, so I think we can live with it.
Can you share packages and stuff like that in your common authentication?
Yes. Yes, so the question was around can we share packages? Yes, Ghost packaging was initially basically based on just sort of GitHub repos or other Git repos. They've recently added the Go module system. We just completed migrating all our stuff to Go modules, so we've now got some internal modules that we use for shared authentication code, shared boilerplate around database connections, and a myriad of other things. Yep.
Do you find Swagger constrains you, or kind of constrains you in any way with developing APIs?
The question was, do we find Swagger constrains us? I think mostly no, because banking is not that exciting. There are a few interesting edge cases around dates and around sort of array type parameters that can catch you out. They have made some improvements, particularly on the array parameters thing, that's made life a bit easier. But a lot of our interfaces are relatively simple. Get me the details of this transaction is not a complicated call. Yep.
I'm not 100% familiar with Swagger, but if you have a payload that's JSON and you can run your code generation, will that also generate like a kind of a struct?
Yes, yeah, so it generates a model struct, and you can, where was I? You can see that in here.
Second, repeat the question.
Yeah. So the question was around JSON payloads and kind of posting them and getting them back. So yes, you can define the structure of those. The Swagger tooling for Go will then turn that into a struct in Go. You can specify whether or not the parameters as part of the JSON object are required. That'll get mapped back appropriately into Go. So you end up with like pointers to strings that may be nil if the string was not provided, that sort of thing. So it's all pretty easy to deal with, to be honest.
Can I ask a follow-on question about Gorilla Mux or stuff like that? Do you think, what if anything do you feel you lack by not being able to use those frameworks?
So the question was, what do we feel we lack by not using Gorilla Mux? Honestly, nothing at this point. We don't feel like we're missing anything. We expect at some point we might explore gRPC over the HTTP RESTful stuff as we grow and have a larger team, but probably not until next year sometime. Okay.
How many services are you currently running?
We've got about 20 at the moment. Address Lookup is obviously pretty tiny. It does one thing, does it very well. Something like our core ledger service that runs the entire cable of accounts is somewhat less than micro. We're looking at how we can break that down without losing the important sort of consistency from the accounting side. We had a service user management that ballooned heavily, and that recently got split out into 3 or 4 different services to manage sign up versus kind of current users, and a bunch of stuff around emailing was sort of hived out into a comms service. So we're always kind of, when things get too big, we're always trying to look at, well, how can we decompose this a bit and make life a bit easier.
And did you start with a monolith and then decompose, or did you?
We actually didn't, which was quite brave, I think anyway. But it seemed to make sense. We very much have a product of 2 halves, on the banking side and the accounting side, so there was always inherently going to be that split from the beginning. We also knew that we wanted the ability to iterate quickly, hence the sort of microservices type approach. It's quite easy to especially with the well-defined interfaces, iterate on one of the services without really impacting any of the others.
So how often do you find you're actually deploying to production?
6-7 times a day. We 6-7 times a day for back-end deploys to production. For the front-end mobile app, we actually use React Native, which means that there's a JavaScript payload into the mobile app that we host, so we can update that outside of the App Store cycle, which means we can do reasonably fast releases to the app as long as we don't need to touch any of the native code. Otherwise, we're into the usual joy of the App Store and Apple Review, which at least some of you will be familiar with.
Aside from Swagger, are there any other kind of third-party utilities that tend to put into every service, like Prometheus, or what other things tend to be present in every microservice?
Can you repeat the question? Sorry.
Yeah, the question was what other sort of tools and add-ons do we sort of tend to include in every microservice? We make extensive use of the Amazon Web Services SDK. A lot of our services talk back to bits of AWS. It's not just VMs. We use quite a few of their higher order services. We have a bunch of kind of boilerplate using a number of open source libraries around our sort of health checking system, exponential backoff for requests, circuit breakers, that sort of thing, so that the whole system doesn't sort of wedge and deadlock in a horrible way. I'm struggling to name any specific libraries off the top of my head, sorry. Yep.
How do you deal with persistence or migrations?
So all of our persistence is in our core database, which is Amazon's Aurora product, which pretends to be MySQL, but under the hood is, to be frank, terrifying. So none of our containers has persistent state, none of our VMs has persistent state. If we ever had enough customers, we could run a chaos monkey, but right now we don't need enough servers for that to be worthwhile. Our production system is about half a dozen VMs across 2 availability zones. We're looking to add a third. It services 15,000 customers quite happily. Cool, thank you. Oh, one more at the back. Some of the services do maintain their internal queues. We don't have queuing between all the services at this point. We're considering whether we would change that. Probably it's as a result of pulling in a service mesh, something like Envoy or something. Where that's been a problem, we've made sure we've handled it. Something like the address lookup service does not see a huge amount of traffic. It never queues. Cool. Thank you.
Cool.